All right, this is the solutions video to the Honors Algebra 2 quiz 5.0, all the way up through the material that we covered up to 5.5. So this is the self-assessment quiz that hopefully you did well on, and this is how you will check your answers. So we will, number one, rewrite the radical expression, the fourth root of x to the seventh power. We need to write it as an exponential expression. And so that will be written as x to the seventh, or 7 over 4 power. And so the 7 is the power, and the fourth is the root. And so that's how you will rewrite that. If you forget how to do that, we know that x to the half is equal to the square root of x. And so this is 2 and this is 1. And so use that to help you remember the order in which you bring that to a fraction, okay? All right, so simplify the exponential expressions. Remember, it's easier to do the root first. So this is the same as 32 to the fifth root and taken to the fourth power. When we take the fifth root of 32, we want to know what number multiplied by itself 5 times is equal to 32, and that will be 2. And so then you take 2 to the fourth power. 2 times 2 is 4, and we will do that again, and that will equal 16. All right, so now in B, we have 9 to the 2/3 power raised to the negative 3/4 power. When we have a power to a power, we're going to multiply those by each other. So I'm going to first simplify that. So 2/3 times negative 3 over 4. And so the 3's will cancel. This will become a half, and that will equal negative 1/2. And so that is the same as 9 to the negative 1/2. If I want to get rid of the negative, I have 1 over 9 to the half, and 9 to the half is the square root of 9, which is equal to 3. So the answer is 1/3. Now, also, some people like to think of that as essentially 1 over 9 to the positive 1/2. That is the same exact thing because the square root of 1 is 1 and the square root of 9 is 9. Okay. Okay, next, moving on. Um, I have C. So this confuses people sometimes. So I have 1 to the negative 3/2 and 25 to the negative 3/2. So if I put 25 in the numerator, it becomes 25 to the positive 3/2 over 1 to the positive 3/2. Well, 1 to the positive 3/2 is just 1. So I could have just essentially taken this expression and said um, 25 to the positive 3/2. And so I have to take the square root of 25 first because it makes my life easier, then cube it, which is 5 cubed. 5 times 5 is 25 times 5 is 125. Okay. D, I have 64 to the fourth times 64 to the 12th. I need to add the fourth and the 12th powers together. That means I have to find a common denominator. That will become 3/12 plus 1/12, which is equal to 4/12, which simplifies to 1/3. So this becomes 64 to the 1/3 power, which is the same as the cubed root of 64. What times itself um, 3 times is 64, and that is equal to 4 times 4. 16 times 4 is 64, so the answer is 4. Okay, moving on. Number 3, identify the domain. So what values of x are allowed for the function that is given. And so we have an even root, or radical, excuse me. This is the square root. And if we have now 2 rules for domains. I can't divide by 0, and I cannot have a number less than 0 underneath the radical. So we know that 4 minus x has to be greater than or equal to 0, because we can't take the square root of a negative number. Because, for example, the square root of negative 16. what two numbers times itself will give me a negative 16, and there are none. Okay, so nevertheless, then I will take negative, whoops, negative x is greater than or equal to negative 4. I divide both sides by negative 1, have to flip the sign, so x has to be less than or equal to 4. That is the domain. This is the domain. This is all my available inputs for that function, okay? Now I have the same request for b. We cannot divide by a 0, so this cannot equal 0 in the bottom, the denominator. So I've got to find values of x that makes that expression 0. So we're going to factor it first. So I've got to find two numbers that multiply to negative 30 and add to negative 7, because I have a something other than 1 in front of my x. And so that will be negative 10 and positive 3. So I have negative 10 and positive 3. Those add to negative 7, multiply to negative 30. Then I bring my 2x down, and then I divide by 2. And so I find that to be x minus 5 and 2x plus 3. Now I want to know what values of x in that expression will create 0. So I know that either x minus 5 is equal to 0 or 2x plus 3 is equal to 0. And so I find the values of x. So x is equal to 5 and x is equal to negative 3/2. Well, we don't want, so we now know that our domain is essentially all x or all real values except for 5 and negative 3/2, because if they were those values, then I would be dividing by 0, and that would not be allowed. The function is not defined. Okay, moving on. Number 4, use the graphs of f of x and g of x to find the values. So we have to understand what this notation means. This is the same as g of negative 4 minus f of negative 4. I highly recommend that you follow this procedure. So now I need to find g of negative 4. So I have to go to the graph of g. So the input is negative 4. That would be my x value. And I go down to negative 4 for x, and which is here. And I go up and find what my output is, which is right there. And so I know that that is 4. So the value of g at negative 4 is 4. Then I have to subtract the value of f of x at negative 4. So I go to negative 4, which is my x value, and I find that my output of f of x at negative 4 is a negative 5. Negative 5. So I have 4 minus a minus 5, and that is equal to 4 plus 5, so that is equal to 9. Be very careful to keep track of your negatives. All right, B, f of g of 6, so this can be written as f of g of 6 is equal to what? So I've got to go find g of 6. So that means that I go to x value of 6, go find what the value of g is, and that is a negative 2. So now I'm going to say f of negative 2. Now I got to go find what negative 2 is on the graph. Sorry, what the value of f of x is when x is negative 2, and I find that to be negative 3. Okay. Be careful to distinguish between the multiplication symbol and the composition symbol between B and C. So this C is f of 0 times g of 0. So we need to go find f of 0. So go to the f of x graph, go to x equals 0, go find what the output is, and that is negative 1. G of 0 is at 0, I have a positive 4. And so -1 times a +4 is -4. Okay. Now in 5, we're doing the exact same thing, except we're using table of values. So I have, this is written as f of 0 plus g of 0. And so that will be, okay, so I got to go find what the output of f of 0 is. So we will use yellow. So I go to 0, the input x of 0, f of x at that moment in time is 1. And what is g of 0? And that is a -3. And so 1 plus a -3 is -2. Okay, this is written as f of g of -2. So I got to go find what the value of g is at -2. So the input is -2, g is 0. So now I find f of 0. And so I go look on my graph, f of 0 is 1, which was yellow again, right? So if I have an input of 0, I get an output of 1 for f. And so my answer is 1. Okay, C, f of 2 divided by g of 2. So what is f of 2? Well, I go to my input 2 and I find that to be 3. I'm sorry, -3. And g of 2 gives me an output of -1. -3 divided by -1 is a +3. Okay. All right. Number 6. The number of green M&Ms and blue M&Ms in a candy dish can be modeled by the functions g of x is equal to 50 minus 5x and b of x is 60 minus 10x respectively. For these functions, x represents the number of days that has passed since the candy dish was refilled. Find and interpret in context of the problem g minus b of 3. This is the same as g of 3 minus b of 3. Now for every x in g, I got to plug in a 3. So I take g and I plug in 3 for x. So 50 minus 5 times 3, that's 15. So 50 minus 15 is 35. So that is the value of g of x at 3. Then I take 3 and plug it into x for b of x. So 60 minus 30 is 30. Okay, so the answer is 5. Now, what does that mean? Okay, what was x? X represents the number of days since the candy dish was refilled. G was the number of green. B was the number of blue. So 3 days after it was refilled, there were 5 more green M&Ms than there were blue. So there were 5 more green M&Ms than blue. Three days after the dish was refilled. Now it's important you remember the 3 days because it wasn't the next day, it's not the same. So the 3 matters, okay? So that's how you would answer that. Number 7, given f of x is equal to x plus 5, g of x is equal to negative x plus 25, find the requested items and additionally state the domain and range for each combination or composition. Remember, we have to do this before we simplify. So the first one is stated g of f of x. So essentially, we take f of x and we plug it in to the value of x within g. And so what do? Now you have to be very careful. F of x is x plus 5. So we will have a negative, and then in parentheses, the x value, which is x plus 5, and then that is squared, okay? And then plus 25. This negative is outside of the parentheses, and the x plus 5 is the item that is squared. All right, so that is the answer. We do not have to simplify. What is the domain? Okay, so this is actually a quadratic equation. It's written in a vertex form. And if you recall, quadratic equations, we have no restrictions on my x values. X values can be all reals. So my domain, my input, is all reals. My range, this has a reflection. It has an x-axis reflection. Okay, so it's concave down. The vertex is let's write that down. The vertex is equal to -5 and 25. So I have to go to -5, and you think about this, 25, there's my vertex. So it has a maximum because of this reflection. And so this range is y is less than or equal to 25. Okay, so this is the answer. All right, B, g of x divided by f of x. This can be written as g of x divided by f of x. And so we have g of x, which is negative x squared plus 25 on top. And on the bottom, we have x plus 5. All right, the top can be simplified. We can factor out a -1, and that will become x squared minus 25 divided by x plus 5. The top now is in a form which is a perfect, a difference of squares. So that becomes x minus 5 times x plus 5 divided by x plus 5. And we can simplify, and this becomes negative x minus 5, and I'll just distribute that negative back through, and that will be negative x plus 5. So that is the value, and now we got to find the domain and range. Now, remember, on the domain, I have to evaluate the domain before I simplify, and so I have to find values such that x plus 5 is does not equal 0. I can't have that equal 0. So x plus 5 cannot equal 0. So x cannot equal -5. So my domain is x cannot equal -5. Now, at the time I recorded this video and have looked up the solution to this, had what I'm getting ready to do. I don't remember us doing in our notes. Maybe our homework had it, but there actually is a restriction on the range. Okay, so here's the function, right? This is the function g of x divided by f of x. That is the function, and that is a linear function with a negative slope. And so far, we know that we cannot have a value of x at -5. And it just so happens that I have to find the y value that I can't have at the same time, okay? And so if I plug that -5 back into this right here, okay, and find what my y value is, -5 times negative is +5, plus 5 is 10. So I know at 10, at y equals 10, so my range does have a restriction. It cannot equal 10. And so this would be a linear function, and I would have a circle at x of -5, y of -10. Don't think we did one in our notes like this. We'll go back and double check our homework and make sure that I point that out if it's in our homework. A surprise that that showed up on our quiz. Okay, number 8. Graph the function f of x, write the equation for the function f of x that is graphed below. So this is the parent function, f of x, parent function of square root of x. We can see that it has been shifted right by 1 and down 2. Now we expect this graph to go over 1 and up 1, but it went over 1, up 2. And so we have a vertical dilation of 2. I believe that's all we have. So our new function, or instead of our parent function, is going to be f of x is equal to 2 times the square root of x minus 1 minus 2. The negative 1 is under. So here is my shift right. This is my down. And here is my vertical dilation. That is all that I was asked to do. Number 9, identify the transformations of g of x equals 2 times the cubed root of x minus 1 minus 3 from the parent function and graph the function. And then answer some of the other, identify some other things. All right, so let's look at the transformations. This 2 is a vertical dilation of 2. We have a shift right. We have gone right 1. And we have gone down 3. So let's go and think to ourselves what's going on. We have nothing else, I think. And this would have looked something like this. And so now I have to go right 1, down 3. Well, here's my new line. And instead of over 1, up 1, I have to go over 1, up 2. Oops. Instead of over to the left 1, down 1, I have to go over 1, down 2. And so this graph is going to look something like this. Get rid of the red. And so we have to identify some things. Okay, so what's my inflection point? My inflection point is 1, negative 3. What sections are curved up? That's all the values up to that inflection point. So here's where it's curving up, right? So that will be from negative infinity all the way up until positive 1. And then curved down is all of these values, because this is where it curves down. And curved down will be from 1 all the way to positive infinity. Okay, I hope this makes sense. Hope you did well. If there's areas that you need to practice, please do so. I do think that B and number 7, I have to go and confirm that we did a problem like that in our homework. I don't remember having to do a range problem like that, at least in our lecture. So at the time I made this video. Have a great day. Come see me if you have questions.